So friends, grab your coffee, grab your cookie, and maybe wipe off your safety glasses, because today's topic is fertilizer dust. Yes, the dust that somehow manages to stick to everything, absorb moisture from the air, corrode equipment, and still find a way into your shoes. My name is Michael Klepik, and for 15 years, I have been working with filtration systems for fertilizer production, granulation, packaging, blending, and bulk handling operations. Today I will explain what fertilizer dust is, why it behaves the way it does, and how we safely control it. What fertilizer dust really is: fertilizer dust is made of fine particles released during handling of mineral fertilizers such as urea, ammonium nitrate, ammonium sulfate, potassium chloride, diammonium phosphate, monoammonium phosphate, and NPK blends. These dusts typically have particle sizes ranging from 1 micron to several hundred microns. Here is what makes fertilizer dust complicated. First, it is highly hygroscopic and absorbs moisture quickly. Second, it forms sticky clumps when humidity rises. Third, it can be corrosive to steel equipment. Fourth, some fertilizer dusts are combustible under certain conditions. Fifth, particles can bond chemically with moisture and form crusts inside ductwork. So fertilizer dust is not just fine powder, it is an active chemical that interacts with everything around it. Where fertilizer dust appears in industry. Fertilizer dust appears in many operations across the supply chain. The most common sources include: first, crushing, grinding, and granulation of mineral fertilizer. Second, screening and sizing operations. Third, conveyors, transfer points, and bucket elevators. Fourth, blending towers used for NPK production. Fifth, bagging, filling, and packaging lines. Sixth, bulk loading stations for trucks, rail cars, and barges. Seventh, fertilizer storage domes and warehouses where product is moved frequently. Anywhere fertilizer is dropped, mixed, transported, or exposed to airflow, dust appears. Why fertilizer dust is dangerous? Fertilizer dust introduces several major hazards. First, it irritates the respiratory system and eyes. Second, it is hygroscopic and forms sticky layers inside ducts and filters. Third, it causes corrosion of steel fans, ductwork, and housings. Fourth, fifth, fine particles reduce product quality during blending and packaging. Sixth, dust buildup on hot equipment can create ignition risks. Some fertilizer components, especially ammonium nitrate, must be handled carefully to prevent unsafe temperature rise or impact sensitivity. How I capture fertilizer dust at the source. Fertilizer dust requires precise source capture. Because the dust sticks easily and absorbs moisture, the system must control airflow correctly. The best capture methods include: first, enclosed pickup hoods on conveyor transfer points. Second, local capture at crushers, grinders, and screens. Third, flexible hoods for bag dumping and packaging stations. Fourth, fully enclosed bulk loading spouts. Fifth, extraction hoods inside blending towers. For fertilizer dust, I designed duct velocities from 3,500 to 4,500 feet per minute. Anything lower allows wet or sticky particles to settle and block the duct. What filtration equipment works? Best fertilizer dust behaves differently depending on the chemical composition. Here is how I choose the right collector. For dry, free-flowing fertilizer dust, a FOEHN cartridge dust collector can be used when the dust is dry and non-sticky. First, it handles fine particles efficiently. Second, it provides large filtration area. Third, it supports strong pulse cleaning. For sticky, hygroscopic, or mixed dust, when humidity is high or the fertilizer attracts water, I prefer a Baghouse Blizzard. First, it tolerates heavy loads of sticky dust. Second, it maintains airflow even when humidity changes. Third, it is easy to clean and maintain. For highly corrosive fertilizer dust, if the fertilizer contains chlorides or ammonium salts, I often specify: first, stainless steel components in high exposure areas. Second, plastic-lined or fiberglass reinforced housings. Third, corrosion-resistant discharge equipment. The system must withstand corrosive fumes and moisture without failing. Combustibility and safety considerations. Some fertilizer dusts, especially organic blends or ammonium nitrate mixtures, can be combustible. To manage these risks, I include: first, explosion vents sized properly for the collector. Second, isolation valves that prevent pressure from traveling into ducts. Third, grounding and bonding to eliminate static electricity. Fourth, spark detection if high-energy machinery is used. Fifth, discharge systems that avoid dust compression and heat buildup. Fertilizer dust can look harmless, but wrong handling can lead to serious incidents. The most common mistakes I see with fertilizer dust. Across many fertilizer plants, I see similar issues repeat. First, undersized duct velocities causing wet dust to accumulate and harden. Second, metal ducting corroding from fertilizer salts. Third, using dry collectors where humidity requires a baghouse. Fourth, lack of grounding, creating static and ignition hazards. Fifth, inadequate hood design that misses half of the dust. Sixth, failure to control humidity inside the facility. These mistakes reduce efficiency and increase safety and maintenance costs. What I always do on fertilizer dust projects. My approach includes, first, identifying the exact fertilizer chemistry and moisture sensitivity. Second, designing ductwork for higher velocity to prevent buildup. Third, choosing between cartridge and baghouse collectors based on stickiness. Fourth, adding corrosion-resistant materials in key areas. Fifth, installing explosion protection when required. Sixth, designing enclosed capture hoods for maximum efficiency. Seventh, ensuring that all components can be cleaned easily without contamination. These steps create a safe, durable, and reliable system. Fertilizer dust is lightweight, hygroscopic, corrosive, sometimes combustible, and always unpredictable. But with proper airflow, corrosion-resistant materials, and the right filtration equipment, you can manage it safely and efficiently. I am Michael Klepik. Protect your lungs, protect your equipment, and keep your fertilizer dust where it belongs. Inside the filter, not all over your facility. See you in the next video.